Okay, so this lesson is on trig equations. Okay, now this is really important in the whole context of the course, and the main thing here is that we've got to learn how to do it within a certain domain. So I'm going to give you a couple of examples, but the reality is that you just need to practice them. All right, check your solutions and see how you're going. Okay, let's get straight to it. So here's our first example, and what I have here is I have sine, cos and tan, and you can see that sine is the blue, cos is the red, and tan is the green. Okay, so we just need to find what x is. Now, we know how to do this from year 9. We can go x equals inverse sine of 1, and it should give you, if the calculator is in degrees, 90 degrees. Okay, now the problem is there is an infinite amount of solutions. So if I look at the sine wave, which is the blue one, and I'm going to write all over here, I'm going to choose a color that will stand out. I reckon pink will. The sine wave goes, it's a blue one. This is 360 degrees. This is 180 degrees. Here, and go down here, is 270 degrees. And here is 90 degrees, okay? And this value here is 1, okay? And this value here is -1. So you can see that, okay? So when is the sine wave 1? Well, it actually is what our calculator told us. It's 1 at 90 degrees, okay? So, and is there any other time that it happens at 90 degrees? Let's do the 1 all the way across. No, that's the cos wave we're hitting. No, we've gone past 360 degrees, so there's only one solution between 0 and 360. Okay? So if you have more questions on that, please ask in class. But yeah, I don't know what else I can do. So x equals 90 within the given domain. Okay? Really important that we need to use these triangles. I'm just going to write that for 0 and x is greater than and x is less than 360 degrees. Okay, because there's other values where it's 1. For example, here it's 1, but that's in the negative part of it. Okay, let's look at a second example. Now we've got these triangles from our formula sheet. So x will equal what? X will equal, and if we look at our triangles, cos is adjacent over hypotenuse. So adjacent here over hypotenuse gives us 60 degrees. Okay. Now we must do an all stations to central whenever we solve these. So all stations to central. Okay. And I know that this is positive, okay, because it hasn't got a negative in front of it. So I know that this will be in the first quadrant and also in the last quadrant. Okay. Now, there's something else. This domain is between negative 180 and positive 180. So let's worry about the positive 180 first. Okay. So this is 0, this is 90, this is 180, and they're all in degrees. Okay. And that's all I need in the positive realm. And this, our related angle is 60 degrees here. So that means we have a solution at 60 degrees actually. So therefore, x equals 60 degrees. Now there's going to be a second solution because we go all the way to negative 180. And remember, we go, I'll use a different color, negative 90, negative 180, and if we keep going round, it'll be negative 270. So we go that way, okay, and our related angle is 60 degrees. So this angle here is minus 60 degrees, okay. So x also has a solution at minus 60 degrees, okay. And if we go halfway, it's about here, and I don't know if you remember from last page, but this is 90 degrees here. So about halfway. That is about 60 degrees. It's not as accurate doing this, but yeah, those are our two solutions there within this domain. Okay, so use all stations to central to help us answer these questions. All right, now finally I'm going to do a question that we need to substitute for. Okay, so the issue is that we have 2x here. So what I'm going to do is I'm going to let u equal 2x, so that what I've got, tan u equals root 3. Now I've got these triangles, and I can see that at 60 degrees will be the answer for u, because opposite over adjacent, which is tan, is root 3 on 1, which will reduce down to root 3. So I can go, therefore u equals 60 degrees. But I'm looking for something within this domain. So what must we always do? Must always do all stations to central. Okay. Now, because it's positive, it must be here and it must be here. Now also, let's write in our related angles. So that's 60 degrees there and 60 degrees. Now remember, the related angle is always from the horizontal to the ray. So it's there. So it's from the horizontal to the ray down there. Okay, so this one, it's just 60 degrees there, so that's 60 degrees. Now remember, that's 0, 90, 180. So we've got 180 plus another 60, so that's 240 degrees. So u equals 60 and 240 degrees within this domain. Now, we know what u is, but that is not what x is, all right? Okay, so we have to substitute back in. So we've got 2x equals 60, 240, okay? Now, there's a problem, okay? And the problem is our domain. So I'm going to write it here. I'm going to go u, and I'm going to go 2x, 360, okay? Now I need to find what the answer of x will be. So I need to divide, I need to get, let me start again. Our domain is this, okay? But we need to get 2x, all right? So I need to multiply both sides by 2. 0 times 2 is just 0. This is 2x, and what else we have? 720, okay? Which means I need to go around again. So essentially what I need to do is plus 360 to both these answers here, okay? So let's add 360 to both of them. So 360 plus 60 will be 420, and 360 plus 240, well, that gives us 600, I think. If my brain's working properly, it should be right. Yep, it is 600. Okay. Now, so I've got all these solutions with this new domain that's 2x. Okay. Now let's find out what x is. So we've got x equals, and I'm going to divide everything by 2 because I have to divide that by 2. So I have to divide everything here by 2. So we've got 30, we've got 120, we've got 210, and we've got 300 degrees. Okay, so notice that all these numbers fit within the original domain. Okay, that means that we've got all the solutions that we need to get. Now, I do understand that this might be a bit complex, but hopefully you can just follow this through, and then we'll work through them in class also. Okay, peace out.